Now let's consider how we combine impedances that are connected in either series or in parallel. We might get a hint from the fact that because impedances have the units of ohms, we would expect them to combine in exactly the same way that resistances do. And we're going to see that that is in fact the case. So for example, we've got Z1 and Z2 connected in series with each other. The equivalent impedance, Z equivalent, is just equal to Z1 plus Z2. So Z1 equals 3 plus J2, 3 being the real part, sometimes referred to as the resistance, and J2, the imaginary part, also sometimes referred to as the reactance. And a second impedance, Z2 equaling 5 minus J. Then the equivalent impedance of those two connected in series will simply be 3 plus J2 plus 5 minus J, which equals 3 plus 5 is 8. J2 minus J1 is plus J. That's its rectangular form, and we can also write that in its parallel form, which would give us then 8.06 for the magnitude, e to the j 7.13. Alrighty, now let's look at these two in parallel. In parallel, it turns out that, as it was with resistances also, 1 over Z eq is equal to 1 over Z1 plus 1 over Z2. Now sometimes we refer to, instead of impedances, we'll refer to admittances, where admittances are called Y is equal to 1 over Z. So in this case we could say then that Y eq equals Y1 plus Y2. Okay? Alrighty, let's just simplify this in terms of impedances. We know then that 1 over Z eq, we need to combine these two terms to get the common denominator, or to get a common denominator to combine them. So that would be, the common denominator would be Z1 times Z2, and in the numerator would have Z2 plus Z1. Thus, now we can invert them, and we get Z eq is equal to Z1 Z2 over Z1 plus Z2, or the product of the impedances divided by the sum of the impedances. I'll leave it to you to go ahead and plug in Z1 and Z2 on these, but let me just give you that for these values of Z1 and Z2, we get Z eq is equal to 2.2 plus 0.6 J in rectangular coordinates, and in parallel coordinates that turns out to be, or I'm sorry, in polar coordinates that turns out to be 2.28 e to the positive J 15.3 degrees.